Good morning, guys. I got a new device that's going to help me make my notes better. So I'm really, really excited. I hope you notice and benefit from it as well. So we're going to talk about S10, which is relating area and perimeter of similar figures. So for the reminder, similar figures, they are shapes that have congruent angles and proportional sides. Proportional means you can take two fractions and set them equal to each other. So there's a relationship. So let's go ahead and explore first, okay? Let's find the perimeter and area of these similar figures. So I'd like you to do that. So pause it and find it, and then meet me back when you're ready. Okay, so the perimeter of this smaller figure would be, let me see, 10 plus 10 plus 12 plus 12. So that would be 44. I just added up all the sides. Perimeter of my big figure would be, you could do 15 times 2 plus 18 times 2, and that would be 66. Okay. Now, let's find our area. Area is 10 times 12, which would be 120. And then area of my big shape would be 15 times 18, which would be 270. Okay, so what are we doing with these? Well, we're going to compare them. So also, I'm just going to write down what a side length is. I'm going to focus on corresponding side lengths. So I'm going to pick 10 and 15. I could pick 12 and 18. It doesn't matter, just as long as they're corresponding. So a side length is 10, and a corresponding side length on the other side would be 15. So I just want to compare first side lengths and perimeters. So what I'm going to do is compare 10. So I'm looking at my side lengths, which is 10 over 15. Okay, if I were to reduce that, that would turn into 2/3. So that is the ratio of my side lengths, S for side lengths. Now I'm going to look at the ratio of my perimeters. Ratio of my perimeters would be 44 over 66. Now if you divide everything by 11, you'd get 4 over 6, which would then reduce into 2/3. So that's my perimeter ratio. Notice your perimeter and your side length are the exact same ratio. That means we're able to set them equal to each other. Now let's go ahead and look at our area ratio. I'm going to use a different color because it is going to come out different. So my area ratio would be, let me see, I'm doing left to right, small figure to big figure, so it'd be 120 over 270. So first of all, I can trim out the zeros. And then if I divided top and bottom by 3, that would give me a 4/9. Okay, that can't reduce any further. So my area ratio is not the same as my side and perimeter, but there is a relationship there. Please notice to go from perimeter or side length to area ratio, you simply square it. 2 squared is 4, 3 squared is 9. All right, so let's scroll on and see how that looks in practice form. So I really like this visual here. Okay, I found it on the beautiful World Wide Web. So the ratio of sides and perimeters are going to be compared. You can just always compare them. You don't have to manipulate them at all. The ratio of the area is always going to be the perimeter or side lengths squared. Area is always squared. Okay, now this image up top is saying the same thing down here in this theorem, where your area is always squared and your side length and perimeter is always just compared directly. You don't have to square it or anything. Okay, let's go ahead and look. So first of all, we're going to copy and complete this table of ratio for similar polygons. So let me actually extend the table just so you can see what's going on. Okay. So we've got 3 different shapes going on. So this is number 1, number 2, and number 3. Okay, so 3 completely different problems. So if we were first to look at number 1, ratio of corresponding side lengths is 5:6. So what's the ratio of the perimeter? Well, remember, side and perimeter are the exact same. So this would also be 5:6. Okay. Now to get to area, you're going to take the side length or the perimeter length or ratio and square it. So it would be 25 to 36. Let's look at number 2. So if they're giving me the perimeter ratio, I know the side length ratio is the same, 7 to 10. Then I know my area ratio is going to be squared, 49 to 100. And now the last one, number 3, if they're giving me my area ratio to go backwards, you square root these. So that would give me a 9 to 6 ratio. And this would give me a 9 to 6 ratio. Now technically, let me go ahead and change colors here. Technically, and on your homework, and good mathematicians do always reduce. So this should have been reduced firsthand, because 9 over 6 can also reduce. So for example, 81 over 36 can reduce. If you divided both numbers by 9, you would get a 9 to 4 ratio. Okay, and then square root of 9 is a 3, and square root of 4 is a 2. And then, I don't want to, so I'm going to rewrite this as 3, but better. So really, guys, everything should be reduced. This was just used as an example, but do make sure you are good mathematicians, so reduce everything. All right, so now we're going to get into problems that you're going to see on your homework. Figures below are similar. That's going to happen every time, and the labeled sides are corresponding. Okay, great. So they want me to find my missing perimeter. So what I'm going to do is set up a ratio between sides and perimeter, okay? So I'm simply going to go, and I like to keep in order, so I'm going to go left to right. So 6 is to 7. 6 is to 7 as perimeter 1 is to perimeter 2. Perimeter 1 is 24. Perimeter 2 is unknown, so I'll call it P2. So then you just simply cross multiply. So 6 times P2 is 24 times 7, which is 168. Let's divide by 6. So P2 is 28. All right, let's look at another one. Figures below are similar and the sides are corresponding. Okay, good. What is the area of the larger triangle? Okay, so when I compare side lengths to area, side is to area. And remember, area is always squared. So what does that mean? Well, let's go ahead and compare them. So I'm going to go 6 is to 9, as area 1, which is 36, is to area 2. All right. So when I compare side lengths to area, you cannot just jump in and cross multiply. Okay, you cannot. What you have to do is make sure they're in the same dimension. So for example, side lengths are in millimeters because that's what they gave us. And then area is millimeters squared. Oop. You know what, let me give myself more room here. So area is in millimeters squared. So in order to cross multiply, they have to be in the same dimension. So what I'm going to do is you have to square the side length, because then that'll make it millimeters squared. So I have to square my side length ratio. So that would be 36 over 9 equals 36 over A2, area 2. Okay, so in this case, my numerators are the same, so my denominators have to be the same because they're equal. So 9 is going to be equal to A2, so my area is 9. You could cross multiply here and get that same answer. Okay. So the figures below are similar. The perimeter of each figure is given. So they gave me perimeter of each figure. What is the ratio of the side length of the larger to the smaller? Okay, they just want ratio. So larger to smaller. So order matters here, okay? So all you're going to do is compare them. So they want me to compare side lengths. Well, I know they gave me perimeter, but we know side is the same as perimeter in terms of ratios. So if I can set up a perimeter ratio, which is 36 over 32, that would be the same as a side length ratio. So all I need to do here is reduce it. 36 over 32, let me see, if I divided both by 4, that would give me a 9 over 8. All right, so here's the thing, guys. If you wrote your answer like this, they're actually going to say wrong, and you're going to be like, what? I'm right. And you are, but they're being very specific. Write your answer as the ratio of two whole numbers separated by a colon. So that means you would write your answer as 9:8. They're very, very specific. If they weren't specific, both would be right. But because they're giving you specifications, follow them. All right. Here's our next one. So this one can be a little tricky because they're giving us the area of each figure and they want the ratio of side length. So we know side length compared to area is always squared. And let me see, they want, what is the ratio of the smaller rectangle to the larger? Okay, so smaller first and then larger second. So first of all, if I were to set up my area ratio, so that would be 25:81. Now they want the side length ratio. This is what I'm looking for. So to go backwards, you're going to square root. Okay, this is like what we did in the table, I think on our third example in the above notes. Square root of 25 is 5. Square root of 81 is 9. So my ratio is a 5:9 ratio. Okay. Figures below are similar. Labeled sides are corresponding. So they gave me side lengths, and they want the ratio of the area. Okay, so this is going to be the opposite of the example we just did above. So we know side length to area ratio. Area is always squared. And let me see. They want the larger to the smaller. So I'm going large to small. So my side length ratio would be a 2:1 ratio. So to get to area, that means I would have to square it. So 2 squared is 4. 1 squared is 1. Oops, I think I want a more dramatic color. Okay, so to get there, you'd have to square it. So my answer here would be a 4:1 ratio. So if you haven't noticed, I like to work in fractions, and then I'll put my final answer how they prefer to see it. All right, that concludes our notes for today. As always, I'm here for any questions, so just shoot me an email, and I'd love to hear from you guys. Have fun with this one. Bye.